Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the substrate. The alkene shown is 8A methyl 3, 4, 4A, 5, 6, 7, 8, 8A octahydronaphthalene with an exocyclic double bond is equal to CH2 at the ring junction, i.e., the CH2 is equal to group is attached to the C8 a ring junction carbon which also bears a CH3 group on a wedge bond. This is effectively a methylenedecalene. Step 2. Hydroboration oxidation mechanism. Hb adds in a SYN, CIS fashion across the double bond, anti-Markovnikov, SYN addition. Boron goes to the less hindered phase of the exocyclic is equal to CH2, and H goes to the same phase simultaneously. The subsequent oxidation, H2O to now H, replaces B with OF with retention of configuration. Step 3. Stereochemical analysis. The exocyclic is equal to CH2 is at the ring junction carbon. The CH3 is on a wedge, coming toward viewer, axial on top. Boron can approach from either the top face, same side as CH3, i.e., SYN to CH3, or the bottom face, opposite to CH3. Both faces are possible, giving to diastereomeric alcohols. Step 4. Determining the products. Because hydroboration is SYN addition and the carbon bearing the new CH2 group becomes a new stereocenter. Attack from the bottom face, opposite to CH3 wedge B adds to the bottom face of CH2, H goes to ring junction from bottom or ends up on the bottom face, dash, H at the new CH2 position. This gives a product where the CH2 becomes CH2 with OH configuration corresponding to bottom face delivery. Looking at the drawn structures, this corresponds to structure 3, H on dash, or on wedge at the exocyclic carbon, consistent with one diastereomer. Attack from the top face, same side as CH3 or ends up on the top face, wedge direction. This corresponds to structure V, both H and OH on dash, i.e., the other diastereomer. Step 5. Why other options fail. Options I, 2, 4, and 6 show incorrect stereochemical relationships at the ring junction or the hydroxyl-bearing carbon inconsistent with SYN addition from either face of this specific methylenedecalene system. The transdecalene framework with the defined CH3 wedge restricts which faces are accessible and what the resulting stereochemistry must be, ruling out pairs A, B, and C. Step 6. Conclusion. The two products of hydroboration oxidation are 3 and V, representing SYN addition of O and H to the two faces of the exocyclic double bond. Therefore, the correct answer is D. Therefore, the correct answer is option D.